Hi Pre-Calc, I'm going over some homework questions. So this is number 17 from 4.6. Okay, so remember, if you're drawing the secant or the cosecant, you need to use the reciprocal function. And you don't want to change anything, you simply want to replace it with the reciprocal function. So if anything is added, multiplied, subtracted, divided, do not change anything except the trig function itself. So we're going to use this to draw that one, okay? So the reciprocal secant is cosine. I put up the standard table for cosine, so now I'll just go ahead and do the modified table. This is not too bad because there's nothing inside the trig that is different, so you can just rewrite the values. In another video, I just went through and solved for all this, but you can simply rewrite the values if there's no changes inside the trig function. It's going to match exactly. All right, but outside the trig function, all the outputs are multiplied by negative and a half, or negative 1/2. So I'm just going to simply go ahead and multiply all these values. So just to sort of be clear, when you have a negative outside of the function, that's a reflection over the x-axis. So like if it had been a parabola, it goes from smiling to frowning. So that's a reflection over the x-axis. This is a vertical compression. The amplitude is going from what is usually a 1 and a -1 to negative 1/2, 1/2, negative 1/2, 1/2. So the waves are getting very tiny. Okay, so here's my new table. So I'm going to go ahead and start with the cosine. I eventually have to get to the secant. All right, let me just get a gist. You always want to get a sense of, okay, the x values are a lot bigger than the y. So the x's are 1.5. The x values are and they're jumping by 3/2, 1.5. So they're 3 times larger than this. Okay, so I'm going to make this pi, everything's just sort of relative, so you just got to sort of figure out, you know, how big or how zoomed in or zoomed out you want to be. It's really your choice. You want to just get it scaled. It's all relative, whether you're like really close in or really far out. It doesn't matter. It's just as long as it's scaled relative. Let me see if I can fix that a little bit. Okay. All right, so let me, I'm going to do the first part in pencil. So now I'm just going to be moving these points that you saw me calculate. I'm going to be moving them over to here. Oh, I didn't do, okay. So if this is 3/2, which is 1.5, then this would be a half. Okay, so these are each a half, so a half is like really tight in here. So this would be like a half here, this would be like negative a half down here. So it's really squeezed, it's a vertical compression. So I don't know, let me see if I can keep this here so you can see it. Okay, so at 0, we're at negative a half. At pi/2, we're at 0. At pi, we're at 1/2. At 3 pi/2, we're back at 0. At 2 pi, we're at negative. Woo! This is a little micro picture here. All right, let me just pull in real quick so I can help you guys see that better. Concave down over here, concave up, concave up. All right, now remember, you want to stretch this out so you have enough of it of the next picture. It doesn't matter which way. I can stretch it a little bit this way. Okay, so this guy would be here, going that way. Okay, so then you just repeat the pattern: middle, up, middle. All right, now that is the cosine. So the secant is going to be the reciprocal of that. So they're all, the function, let me find a good color here so you can see. So what's going to happen is, at all the center point, and I know this is a little difficult to understand if you're first learning it, but at the center point is where all the VAs will cut through. So people tend to always associate that with the x-axis, which isn't necessarily correct, because if the graph is pushed up like 5 units, you don't want to use the x-axis. You want to always use the center point. So it's really, you know, you see there's like one up, one middle, one down. You want to use the middle. All right, so I'm just doing a little bit extra so you have it. I'm trying to do it in red so you can see the different graph. All right, now it's going to touch, the secant graph is going to touch at all the hills and valleys. Okay, because they're equivalent there, but then after that, they're reciprocal, so they're opposite. As one gets smaller, the other one gets larger. All right, now that's, one cycle is one up, one down. The core one is actually, we usually would say more this way. Okay, so one cycle is one up, one down. So I'm actually drawing 2 cycles here. On the test, please draw 2 cycles. You can leave this on the test. It won't mark it wrong if you leave the cosine, but really, just so you know, we just use that for guidance. So technically it's like not there. We just use that as like a tool. So I'm gonna now pull it away because these are floating parabolas. These are floating parabolas. The original graph gives you like how tight in they are to the axis, and they also helps you figure out the VAs, which tells you how squeezed they are. Okay, so this is the final graph. A secant function is floating parabolas. By the way, so is the cosecant function. That is also floating parabolas. Okay, and there you are. I hope you found that interesting. Okay, catch you. Bye-bye.